Okay, we are going to go through 3A together here. Um, so with 3A, let's read the prompt. Um, 507 business students were surveyed. 333 indicated they used an Apple OS for their computer operating system, while 25 indicated they utilized Chrome. Very little data is known about students using Chromebooks in college. However, it's believed the satisfaction with Chromebooks will be different. Because F-test for equality of variance noted the variance of the two groups was not um, significantly different, the variances were pooled. So down here, the F-test, you can see that the probability is 0.7181. In other words, we were looking for differences between them, and it was saying these variances are very similar. The probability of them being from the same group is 0.7181. So yeah, the F test is a really great way to determine whether or not we should pool the variances or use the variances, use separate variances. Okay, so first of all, let's look at the hypothesis. Um, let's pull this up here. So let's go to 3A. So, what is the null and alternative hypothesis? I'm going to do, let's see, H sub 0. And then I'm also going to do H sub 1. So what is the alternative hypothesis? Or sorry, what is the null hypothesis? So the null hypothesis, just like what we did here, we're going to do something very similar. Okay, but instead of using mu sub s, we're going to use mu sub a and mu sub c. Okay, so let's do this. Mu sub a is equal to mu sub c. And I'm gonna see if I can zoom in a little bit. There we go. Mu sub a is equal to mu sub c. And the reason why it's equal to is because there's no direction indicated. It's just saying it's going to be different. So the next one, the alternative hypothesis, is going to be mu sub a. Let's see if we can insert a symbol. Oops, symbol. Does not equal, or maybe just be easier for me to copy. Okay, so mu sub a does not equal mu sub c. What's the level of significance? Well, this is kind of perplexing here because in this particular question, if you look in here, nowhere does it tell you what level of significance to use. So the question is what level of significance should we use? We could use a 0.1, we could use a 0.01, we could use a 0.05, and each one of those means something different. If you use a 0.1, you're saying I'm okay with a 10% chance that I'm going to reject the null hypothesis when the null hypothesis is actually true. If you do a 0.01, you've only got a 1% chance of that, but it increases your the probability that you're going to have type 2 error. And so I'm going to go with a 0.05 because it's halfway in between 0.1 and, well, kind of halfway in between 0.1 and 0.01, and so there's a 5% chance of committing type 1 error, but there's also less of a chance of committing type 2 error than utilizing a 0.01. So we're going to use a 0.05. So what's the test statistic? Now, I could have used Z, because this is a very large sample, and really I should have used Z, but what I did is I used T. And I'm going to tell you why in just a minute. Really, it was just to prove a point. But I'm utilizing T. And so what is the decision rule? The decision rule is, first of all, let's pull out the T distribution. Okay, so we've got the T distribution right here. So how many degrees of freedom do we have? We have 356 degrees of freedom. You can see the 356 right here. That's 356 degrees of freedom. That's a very large sample. So, and as the sample gets larger and larger, the values, the significance values in the T distribution approach the Z values. So coming down here, I'm going to zoom in a little bit. You'll see on the left-hand side, we've got the degrees of freedom. We've got, and finally it gets to 100, and then it goes to 120, 140, 160, 180, and then 200. And anything beyond 200, it refers to as just infinity. Okay, so, which these values down here are identical to the Z values. So you see 1.96, 1.645, 1.282, 2.326. Those are all identical to the Z values. So you've got this T statistic right here that is more or less identical, or it's very close to the actual Z value. And the way that we're going to interpret it is we're going to put it against the critical Z values. So 0.05, let's look at 0.05. And we've got a two-tailed test. So level of significance for a two-tailed test for 0.05 is 1.96. So what is a decision rule? If Z is 1.96, if Z is less than negative 1.96, or if Z is greater than 1.96, reject the null hypothesis. There we go. So, coming over here, you can draw 1.96 right here. You can draw 1.96 right here, and then, or negative 1.96 and then 1.96. And if the T statistic is beyond that, then we reject the null hypothesis. So let's take a look at the Z statistic. So we've got a Z, or the T statistic. The T statistic is 0.386. Now, is this a one-tailed or a two-tailed test? This is a two-tailed test. So the two-tailed test, the p-value for the two-tailed test, you can see it right here, is 0.6997. In other words, it's very likely that this value that we got, the apples, the apple mean compared to the Chrome mean, it's very likely that they happen just by chance, and there's very little difference between them. So the p-value of this is 0.6997. So what is our decision? We fail to reject the null hypothesis. So interpret your results. Our results are, okay, so we've got a difference of 1 point. Okay, so our results are the difference of difference in means between groups of 1.153 is small enough of a difference to have occurred by chance. There is no significant difference between these two groups. So that is how I would interpret the results, saying, hey, there's really no statistic, there's really no difference. So that is 3A.